Hi everyone, welcome back to the final workshop in the WorldCoin Educate series. Once again, we have DC Builder joining us today to talk about the future of WorldCoin technology.
So welcome to the last episode of the Educate series. I was thinking, since we were talking about all the different things within WorldCoin, right? Like we have the orb, we have the biometrics part, the cryptography, the use cases, so many different things that we covered. When I was originally creating the schedule for this and the general table of contents, I was thinking like, what is the best way to sort of end it on? So I was thinking that the best way is to sort of recapitulate a little bit of like what we've covered in the last seven series or 7 episodes of the series, and sort of get a look ahead and summarize so like what are the future points of where we're going from here. So like in the table of contents, we're at the end, and a good intersection here is that the reason why I believe that these sorts of educational resources are important is that sometimes people building these technologies like myself within WorldCoin directly, we sort of get too deep in the rabbit holes, and sometimes it's like hard to pull out of the rabbit hole and sort of tell other people about it, educate them, say what sort of things we're working on. And if you're trying to build a decentralized protocol and a project that sort of grows to become a part of daily life of most people so that you improve the internet, you want to create a protocol that is open source, that is has general mind share in the minds of people, so people can contribute to it, right? Like there's multiple different parties contributing to it. There's multiple different people who know how it works at depth in various aspects, just like Ethereum, right? Ethereum has a lot of different aspects of it, and there's so many different people working on it. There's thousands and thousands of developers, researchers, engineers, marketers, business development people, founders, companies, like so many different things that are part of Ethereum and their ecosystem. And so the Educate series is sort of like a small little step towards that direction, so that we are not just us building it, but we want to bring you guys along. And so one of the ways that we do that is, as in this slide, a specific slide indicates, is the Human Collective Grants. And so we have this grants program at the WorldCoin Foundation, which is aimed at helping onboard open source developers and researchers and engineers to build alongside us and to help us develop this thing that is WorldCoin, right? And all of the different aspects of the WorldCoin technical ecosystem. And so I personally lead the technical side of the grants program. So I help source grantees to solve a bunch of the different problems that we have within the WorldCoin sort of tech tree and further beyond. And I help review the applications, and then I'm a sort of technical point of contact and sort of almost like project manager for the grants program to get the projects to completion. So some of the topics, so like if you've found any of the topics that I discussed interesting, or you have any expertise for those watching, if you have any expertise like within any of the sort of topics that are at hand and more, right? So you can go to that link. And then there's another link, which is worldcoin.org/RFP. The letter R, the letter F, and the letter P stands for request for proposal. So these two links, I'll also share them in the chat briefly. I'll just type them out. Give me 1 second. I need to just full screen the other screen. Yeah, live things. What a thing. Great. So worldcoin.org/RFP. So this link is where we have the request proposals, and the community grants is what you can see is where you have like the main page for the grants program. And so you can take a look at sort of like what are the open problems that WorldCoin generally cares about. And we've talked about a lot of these different ones upon the within the different episodes that we've had. So this is sort of like how I want to get started, just framing it like this. So now let's get into the what are the sort of latest things that we're doing, the things that we want to do, and sort of the motivation behind them. Since now you have some context from the last 7 episodes for those who watched them. Cool. So let's start with the Orb software and hardware. So we had Dan from Tools for Humanity, Dan Gershovich. He's a great engineer. Has worked a lot on the Orb for the last 2, maybe 3 years, I think. And he's given me some points to share here today, async. And so what are sort of like some of the major bottlenecks within Orb software and hardware right now, and sort of like what things we care about currently? So one which the general community cares about is increased transparency, right? Like maybe you've seen controversy around WorldCoin and the Orb and the whole notion of biometrics, right? Like, why are we imaging biometrics? Why are we using biometrics? How is it privacy preserving, right? Like, you can technically sort of, right, like just upload the image and store it. So how do we have a guarantee that you're actually not doing this? And how do we actually guarantee that you're doing what we say you're doing, or what you say you're doing, right? So for that, you need to have a lot of transparency. So the first way we got started with transparency is by open source, by open sourcing both the hardware and the firmware. So if I show you, I can show you some links. So github.com/worldcoin/orb-software, right? So this one is the repo, the GitHub repository with all the code for the Orb software. Same for hardware, you just change software for hardware. And also we open source the biometrics pipeline, right? So these are sort of like the tiny little baby steps that you need to start doing so that you can build public trust, right? Like open source the things that you say you're doing, and then expose different verification mechanisms so you can actually verify the claims you're making. So ones that we did that you can sort of trust to some extent is external audits, right? So we had external audits from people like Trail of Bits, it's an auditing team, really famous one. Then for cryptography, we had Least Authority, and for things like smart contracts, we had Nethermind Security. And so for these things, like we're increasing the amount of security audits we're doing from external firms over time. We're sort of having different parties confirm that we're doing what we say we're doing when it comes to how does the like Orb cryptography is set up, like how is the Orb connection with the phone set up? Are you actually running the firmware you say you're running within real Orbs that are deployed out there? So some of the things that are going to be worked on within Orb software and hardware are sort of new mechanisms to enforce or to allow people to sort of introspect into the actual system that is running in production. So more components of the Orb are going to be open source. Also, there's going to be new versions of the Orb, right? So you need to open source newer iterations of the Orb that have new hardware and maybe new firmware. There's going to be a removable storage device that you can essentially like withdraw from the actual hardware, like the Orb itself, and then you can inspect it. Like you can see like what firmware is actually booted into it. Is it provisioned correctly? So this allows third-party auditors that come and can sort of audit a real-life location to see that, hey, has this Orb been tampered with, or is this a real Orb that is running the open source version that everybody is contributing to? Yeah, so that's like sort of like the first gist of it. So more audits, more transparency, more components to be open sourced. The second part is manufacturing, right? So you can think of hardware as a really hard thing to do. I think that's the name why they called it hardware, right? Like not only that this has like this physical tangential sort of aspect to it, but it's just really hard to build hardware. It's one of the hardest things, right? Like things like cutting edge silicon or anything. So we're not doing anything that hard, but even like manufacturing your own device is really hard, especially because there's so many moving parts to it, right? Like you need to have suppliers, you need to have assembly, provisioning, then you have to customize your own operating system for it, distribution pipelines, right? Logistics around it, then operation. You have to manufacture enough of them. You have to have some runway, right? Like you need to distribute them, operate them. So this is sort of like a central point of failure of the WorldCoin project, right? Like it's the building block, like the base of the WorldCoin project, because without it, you don't have SIB resistance. But on the other hand, you also need it to be somehow decentralized. Otherwise, if Tools for Humanity goes under, the WorldCoin project cannot move on, right? So how do you move away from this pickle? Well, you need to create an ecosystem that allows you to build multiple of these orbs, right? So through having increased transparency, you can also have increased redundancy, right? Because third parties can just take your design, alter it to their needs, and maybe innovate upon it and have another one. So another thing that we care about is creating sort of like redundant supply chains. Not only that for Tools for Humanity, but eventually for full orbs, right? So that there's third parties that are completely independent off of TFH and other parties like the WorldCoin Foundation, but maybe funded by the foundation originally to essentially start building orbs as well. this will severely or like really strongly will reduce the sort of points of failure. I was just looking at the questions. Brian, what kind of support and documentation is available? So it depends of what you mean. When it comes to like the Orb software, Orb hardware, and all those sorts of things, they're documented. Like the repos, if you open it, they're documented. Same for the Iris, but like everything that we open source has a documentation for internal purposes, so that we know what we're doing after the fact, and also external. So I guess that answers your question. For World ID, also have a documentation for everything we build. Essentially, has a documentation either in the code itself or within some external documentation that we made for it. And then we have educational resources like this one. So yeah, so we at the foundation, we're sort of trying to create this sort of movement, decentralized manufacturing as well, and working with TFH and other parties to sort of help this happen. Another big problem is scale, right? So as you might think, building hardware is hard, but distributing it to all the parts around the world in order to have World ID adoption is the hardest part, right? Like distribution is always the bottleneck for any major project ever. It's not just in crypto or Web3 or just web technologies, but any product, right? Like if I make a chair, well, I need to manufacture lots of chairs in order to be able to distribute them, whatever, so that I can have a business or to have something useful. So the same happens to orbs. So you need to manufacture thousands and thousands of orbs and have availability of orbs within the locality that is like close to the actual users. So this is going to take time, but we're working on it, right? And also we're working on different iterations of the orb to make it more cheap to manufacture, more performant, or just change some different form factors about it to sort of make it more scalable at large. So yeah, so those are like the three main focuses of Orb software and hardware at the moment. And of course, there's security and some other things as well. But these are sort of the ones that the public usually cares the most about. So let me move on to the next slide. So biometrics. So we had Tanguy from the Tools for Humanity AI team present about biometrics. I think it was like the third presentation or something, or fourth maybe. And so I'm going to be talking about some of the points that he mentioned while he was talking about the biometrics presentation. So to reiterate, I'm going to explain sort of the higher motivations for the AI team in general. So what does the AI team do? So there's two main aspects, right? Like you're getting some signals from the Orb hardware and software, right? So you have these different cameras, right? You have like an RGB camera, you have an infrared camera, maybe you have a field of depth sensor, a light sensor, temperature sensor, right? That through the infrared, and some other things, right? So you can create a sort of map of data about the thing that is in front of you, right? And using this data field, you're able to sort of measure whether the person whether the thing in front of the orb is a human or not, right? So this is the thing number one, right? Like proving liveness, ensuring liveness, and making sure that it's not able to be spoofed, right? If you put a picture of a human, just like a piece of paper, you print on a picture and put it in front of the orb, the goal is that it would not work. You would not be able to sign it up because the orb will detect that it's not a 3D face, you know, like there's no heat map behind it. There's some anomalies, you know, like this is like part of the task of the AI team, because the AI team has a lot of adverse detection, right? So like when you're attacking the orb, you're trying to sort of fool the system. There's a lot of anomaly detection models that are trying to figure out whether somebody's trying to spoof the input of the signals that come from the orb. So this is part of the AI team for proving liveness, that there's a real human being in front of the orb. And the second part of the biometrics part is the thing that ties to the irises and just the uniqueness part of it. So like, how do I prove that not only is it a real human, but it's a real unique human, which is the core part of World ID, ensuring uniqueness. And so these are the main things that the biometrics team cares about, and therefore all the goals and future things that we're working on are directly stemming from these two needs: proving liveness and then proving uniqueness. So that's the first point. I'm going to explain all of the acronyms that I use, so don't worry. So I mentioned two acronyms, FMR and FNMR. So what these stands for are false matching rates and false non-matching rates. Tanguy talked about this earlier, but essentially it means that when you're getting signed up by the orb, there's two options that can happen, or three, right? There's the happy case where the person just gets verified and everything is happy and dandy and they get inserted into a set of verified users. That's the happy path. Nothing to talk about there. And then there's two sort of bad paths or sad paths, if you will. One bad path is that the user is unique, but the orb will tell them that, hey, you've already signed up before. This is a false matching rate, meaning that your iris code will match against one that is already in the database. However, your iris code is not in the database, but there is a collision between some existing from another person, right? So this is a false match. And this can happen because the way that the biometrics exist, or the ways that they function in the system that we implemented, is that there is some output space of possible iris codes and vectors. You can think of them as vectors. And the more users you have, the likelier it is for you to have a collision, because you have a more populated database. So when you're searching in this database and you're trying to find a collision, it's likelier to have a collision because there's just more data points to collide against. So this is denominated by the false matching rate. And it's a sort of a bad case, right? Like a person is unique, but they collide accidentally because the algorithm is not good enough. The other thing is false non-matching rate. So this is the opposite. The person is not unique. They're already in the set of verified users, but they're able to create another iris code, and they will not collide against the iris codes that are in the database. And so they'll be able to be inserted twice or maybe n times into the database, right? So these are both sort of like the bad cases. And so one goal of the biometrics team is to now essentially create a biometrics pipeline that allows you to onboard 1 billion humans without having FMR rates or FNMR rates that are sort of so bad that you would not be able to operate the protocol in the first place, right? Like either you have too many Sybils or you're not able to have enough humans in the data set so that you're able to use World ID, right? Like you just reject everyone when they're trying to sign up because you're colliding against existing members in the set. So minimizing FMR and FNMR like the target goal, so that you're actually able to be inclusive, right? Like you're able to support humankind with this system. So this is the main goal. So this is sort of like what also the second point is about, right? So like if you increase if you minimize FMR and FNMR, you're able to increase Sybil resistance, right? So there's the second point stems from the first one. So you're able to deduplicate the set of verified users and have just like, you're fairly sure or extremely sure that every single person that has a World ID is unique. There's no like multiple World IDs per person, or maybe like a person that cannot enter the system. So a third one is exploring new signals and authentication methods, right? So you can use the iris, but maybe you can use other signals. We've explored those in the past as well. However, they weren't feasible, or you could not really use them for a lot of different things. But moving forward, we're exploring them because there's new research coming up with things like palm prints or fingerprints. There's like a lot of other things you can do whilst preserving privacy as well that you can maybe potentially use. So there's that. So we're exploring different ways of essentially capturing humanness and creating authentication methods that are based off of that in a way that is still privacy preserving. It's the same way that we have right now with all the cryptography that we do, all the privacy preserving things that we do. Brian, what are the potential risks associated with biometric data breaches? So that's a hard question, but the TLDR is we're doing our best when it comes to ensuring privacy from the get-go throughout every single step, right? It's like defense in depth, as it's called. The way that you do that is that even with the iris codes, right? Like the iris codes are not biometrics themselves, but they're biometric derived, right? Like these, the iris code is the thing that you see here. This is the raw iris biometric. A normalized image, and this is the iris code. This is the thing that you're comparing against others to check uniqueness. So these things we're not storing in plain text, as it's called. We're not storing it as it is. We're storing it in an encrypted fashion using secure multi-party computation, which we had Lucas from Tasio talk about in a previous lecture. So that is sort of like the main defense that we have, right? Like we just don't store the data in plain text. We just have it encrypted. And these things are impossible to leak. And even then, they're not able to be associated with a person because we don't collect any personal information. There's like a lot of different things about privacy. I recommend you go to our privacy FAQs. If you just search WorldCoin privacy FAQ, you're gonna get like a lot of like frequently asked questions and replies to them when it comes to privacy. So I recommend reading that. Yeah, so another thing is increasing liveness assurances and robustness, right? So when I mentioned like you want to be really sure that the person in front of the orb is a real person, right? Like the thing that is in front of the orb is a person. You want to know that. And so in order to increase liveness and robustness, you have to increase or improve essentially the biometrics pipeline, many different parts of it. And robustness might mean performance, might mean maybe replicability, right? So it's like every single time it happens, there's like no failure rate, right? Like it never crashes and you have to reboot, whatever. It just works the first time. It's fast, it's good, and it really like has some really strong liveness assurances, and you know that things work the way they should be. Right, so this is also part of the tasks of the AI team. The next point is more about sort of like technicalities, right? So like since we're working with AI models of different kinds that we train ourselves, or maybe we get off the shelf, you need to create better AI training and inference pipelines. So increase performance, make sure that when you're running the AI models on the Orb, they run fast, right? So this is a joint effort between the Orb software team and the Orb hardware team and the biometrics team, right? So like they're working together to sort of create the best form of interface for the AI code to be deployed on the edge. And then for future maybe authentication methods, you can also use things like mobile phones to some extent, but it's again, like these signals would be worse. So they're not as trustworthy as the Orb because of many different reasons, but essentially they're still worthwhile exploring because they can add some form of signal that you could not capture by the Orb, or maybe it's more accessible or something. And then something like increasing privacy as well is something that the team on the biometrics team cares about a lot, right? So how you're able to increase privacy with the iris codes. Maybe you retain less data about the iris code, but you still have the same performance or increased performance without retaining as much information from the iris code. And even then, if it's an SMPC or whatnot, you're still able to do a lot of cool things. Are there any other edge devices besides the Orb or mobile devices? So edge device in general means like anything that is in the hands of users, right? So you can think of computers, like my laptop that I'm streaming this from, like a phone, like a Raspberry Pi that somebody has somewhere, like some robot, whatever, like a microcontroller, CPU, whatever. All of this you would call like edge device, and you would call people developing on edge devices maybe like embedded software engineers. Or I mean, mobile is such a big platform that people just call them mobile engineers, but it doesn't matter. Essentially, like any device that has like a low-powered CPU or a little bit of RAM, a little bit of disk, that's sort of like what you mean by edge device. We are mostly working with phones and Orbs because our app runs on a phone, and the Orb is the other piece of hardware that you require to prove unique humanness. So yeah, those are the two things we work with. We may work with other form factors of hardware in the future, but that's the current state of it. Cool. So we had Daniel and Ryan from the Modulus Labs team and Lucas from the Tasio team explain about zero-knowledge machine learning and multi-party computation. So I'm going to just talk about some brief points that they're working on. So the ZKML research that we're doing is currently that research, right? It's not deployed in production, right? So like one of the future things that we want to do is actually deploy this system in production, right? So what would this thing allow us to do? So the thing that would allow us to do is to, maybe let me just turn on the light quickly so you guys can see me. Yeah, so the thing that allows you to do is create a iris code on the user's device, like on the user's phone, as opposed to in the Orb, right? So the Orb would become just this first part of the thing that I talked about in the biometrics flow, right? You just prove humanness, that it's a real human being in front of it. You're not proving uniqueness, right? So the way it would work is that instead of having all of that be done on the Orb, and then you do this SMPC check with the server to check uniqueness, you do the liveness proof in the Orb. The Orb would take a high resolution image of both irises and will do a commitment to it, a cryptographic commitment to it, through either like a signature or a polynomial commitment scheme. That's besides the point. And then it would store those images with the commitment to the to the user's device. And once you have that on the user's device in an encrypted fashion, right, it can be encrypted with maybe the private key of the enclave of the phone, or maybe like the P256 signature, or the private key of the phone from maybe like iCloud or whatever the user is using to store secure data on their phone. And then with zero-knowledge machine learning, they would be able to create an iris code on the fly from the orb's sort of input data in a fully privacy-preserving way. And then they would be able to permissionlessly insert themselves in the MPC algorithm that we talked about earlier, right? So like you have this graphic on the right when you have like these three participants talking over SMPC. So they'd be able to essentially verify uniqueness in a way where their iris code would never be in plain text. So this essentially means that WorldCoin would never have an iris code in plain text. You'd only have an iris code in a split fashion using these linear secret shares that you can add with one another and perform operations on them within the MPC algorithm, right? So essentially, the thing that would mean in layman terms is that you're able to do everything on the edge, on the user's phone, and WorldCoin would never have the actual iris code of the user. You would only see the iris code in an encrypted fashion on the MPC setup. So essentially, the zero-knowledge machine learning to work together with the MPC would allow you to create such a scheme. And so deploying such a scheme to production is like some of the things that we have in the pipeline that both Modulus and Tasio and other teams are working towards. So another thing is the MPC scheme that we're using right now is good, but there's some things we can improve, both in privacy and performance and a lot of other things. So there's going to be a lot of work on that from both Tasio, Inverstek, and many other teams. And so we're going to be working on that. Some concrete things for those who are technically savvy is that we're going to be using a MPC scheme that eventually will allow you to have more participants. So instead of just having a 2 out of 3 threshold for decryption, you can have maybe like, I don't know, like 6 out of 10 or something, or maybe more. And something else that you could do is have more performance, right? So you can minimize cost of running the hardware, whatever. So it's more inclusive, more people can run it at less cost. And another thing that you care about is total privacy. So not only is the database of iris codes private, but maybe also the query. So like the thing you're looking up in it, and maybe like the distances between the iris codes also private. So it would become more expensive, but more private. So yeah, these are like sorts of things that we care about in the MPC side of things. And you also need to make it performant enough to support like billion human scale. Right, so like if you have 1 billion humans, now you're checking 1 billion iris codes against each other for every new signup. Right, like if you're a new user right now, you only have to check 6 million entries or 6.5, 6.6 million entries of existing verified users. Now that you have 1 billion, you have to check 1 billion items. But checking 1 billion is orders of magnitude, like 3-4 orders of magnitude harder than checking 6 million. And so for that, you would increase the computational load or expenditure by 4 orders of magnitude, which might become unfeasible by today's computers, MPC standards, and such. So you need to scale not only to make it cheaper, but also to make it feasible for 1 billion human scale. So this also is all intertwined, right? Like reducing hardware costs, scaling to more users, making it more performant. It's all sort of part of the same goal. Another item that I have is adding trusted execution environment support. So it essentially means that you're able to use this secure hardware element in order to mitigate some of the problems with MPC, like this honest majority assumption. It's a bit too technical to explain right now, but for those who care, you can use that to sort of mitigate some of the security risks using trusted execution environments. And that is something that Automata is working on together with the foundation. And they just made an announcement today. So if you go to the Automata Twitter, you'll see the announcement there. So maybe let me look at questions. What is the liveness world ID once the user passed away? Right, so there's no liveness, right? Like you're not able to prove a person has a unique iris code if they're not alive, right? The orb would not treat that as a unique human being anymore. But when it comes to like a person that's already been signed up, and if they pass away, well, as long as there's someone who has a private key that has a public key that's been verified and it's inserted in a set of verified users, then it would still be valid, right? So you could still use it. So if somebody else gets it, they could still use it. However, you can just simply have an expiry date, right? So maybe after 2 years, it does become valid. So you have to re-sign up every 2 years and verify your unique human every 2 years. That is something you can do. or maybe the application can request like, hey, this person has to be had to be verified in the last like maybe year or something. Or there's many different ways you can solve it. It's not a hard problem to solve at all. Yeah. So role ID use cases. So we had Ian discuss this, the general gist of what use cases we have. I've listed some of them here, right? So things like discounts, promotions, user acquisition and targeting pipelines, retail and brick and mortar stores, right? Like they can give you discounts and promotions to maybe try out like a coffee from a new coffee shop, or maybe get a discount on some sneakers from a new sneaker shop, whatever. So people using World ID, they know that these people have not bought shoes or coffee from these stores before, because maybe they've used World ID for that. These are some sort of like in-person real demo things you can do with World ID, and we have some teams doing that out in the wild, like in Japan and other places. People have used World ID for these sorts of use cases. E-commerce is an obvious one, right? So like maybe let's say that I'm trying to buy a ticket for the concert of my favorite metal band or whatever, and now they're selling the tickets. I can just run a computer farm that just will bot the website to buy as many tickets as possible with some like offhand credit cards, and then I can buy 1,000 tickets and resell them on the secondary market for 3 times as much. And so the people who are trying to attend the concert, they get essentially a much higher price than the original should have been. And so SIB resistance is really important in these sorts of scenarios. Anything that is like limited edition things, they stop having value when people cannot actually get a hold of them, which is the problem with AI and bots and all these things. So World ID is useful there. Things like voting, governance, democracy, DAOs, right? So anything that requires one person, one action, World ID is really useful for. Voting and democratic voting more specifically, where one person has one vote and one vote only, it is sort of really warranted and a really fair use case of World ID. And so things like organizing and creating coordination mechanisms require such things, such tools. So World ID is an enabler of that. Fair distribution, right? So maybe WorldCoin is fairly, like you can say like WorldCoin is fairly distributed because like only one person with a World ID can claim a share of WorldCoin tokens. They cannot claim more than one unless they're able to get a hold of more than one World ID, which is extremely hard to do. And would have to break sort of the SIB resistance guarantees of the org, the biometrics, the cryptography. There's just so many other things you have to break. So you can have some fair amount of trust of like how fair this thing is if it uses World ID, right? So things like NFTs or like airdrops, whatever, you can use World ID for these such things. There's some DeFi use cases. I have 25 minutes left. Okay, I'll try to speed up. So there's some DeFi use cases. So for those who maybe have used Uniswap, right? Uniswap is an automated market maker. Essentially, it means that you can swap tokens back and forth by providing liquidity to a pool, and people can deposit into the pool one token and withdraw another. So this is what a swap is. And then there's a price associated with the rate at which you can exchange one asset for another within the pool. And so there's this thing called order flow, which essentially means that like how much you can trade on the like volume that you're trading on this specific pool. And so order flow can be toxic if there's like lots of bots that are just wash trading on the specific pool. So for example, if you have a World ID, you can prove to the liquidity pool, hey, I am a unique human and I'm not a bot or some like trading bot, whatever, trying to make money. I'm just a unique human. I'm trying to just buy USDC with my ETH, or maybe like buy something else, whatever, an NFT. And so you can prove to the protocol that, hey, I'm a unique human, so please give me a discounted fee. So liquidity pools have these like fees, liquidity provider fees. So every single time you take from the liquidity pool, you're paying a fee to the liquidity pool liquidity provider. And so you can minimize these pools' fees for the user if they prove that they have a World ID. They prove essentially that they're not a bot, right? So you can have discounted rates. There's also things like reputation systems and credit scoring, right? So if you create a network of unique humans that have some form of reputation, they're not able to just create some reputation, exit the system, enter the system again. Like they're not able to, if they do something bad, like they like don't repay a loan or whatever, this reputation stays with them and they're not able to exit the system easily, right? Or at least there's some sticky reputation. So World ID is something that you can use for that. social networks, right? Like bots on X, Instagram, whatever, anything that has a social network sort of demographic type setup, you want not it to be botted, right? Like if it's botted, then you cannot trust the people posting, and maybe it's just bots that are trying to attack, like information attacks on whatever elections, all sorts of things you maybe have seen online. Blockchains, right? So this also gets into like world chain territory. We are using World ID within World Chain, or will be using World ID within World Chain to do things like gas allowance for unique humans. And human transaction priority, right? So if you're a unique human, you have a direct priority in the ordering of the transactions in the mempool, as it's called, right? So if there's a bot that is trying to maybe, let's say like in periods of high demand of the blockchain, right? Like let's say there's a lot of volatility, right? So people are trading a lot. Your transaction as a unique human will still get through, and all these bots will just have to wait. So right now they'll just price you out because they'll just put the fee so high that you cannot use it. In this case, having SIB resistance is something that is really useful because you can just pay a normal fee and be priority included just because you're a unique human. You're just trying to transact with the blockchain as you should. And you don't care about maybe like all these like speculative traders that are trying to profit off of high volatility periods, for example. There's this thing called MEV, called maximal extractable value. So if you care about that, I recommend you read upon that. It's a really like heavy topic, so it's hard to explain. But I recommend you just Google like what MEV is, or just ask ChatGPT what MEV is in the context of Ethereum and DeFi and whatnot. Web of trust, right? So if you create a network of unique humans, people can create attestations about each other, right? Like if we create like me, Brian, Riddick, Diudone, Adam, like everyone here, we create a network of trust, right? We can just call each other trustworthy. I can say that you're trustworthy, you can say that I'm trustworthy, we can start accruing sort of points of trust. Right now, these sorts of systems don't really work because people can collude, right? Like I can vouch for a bot that it's a unique human, right? And many of my friends can collude to attest to this bot being a unique human, and then to other people it might look like he's actually a real human, but it's not, it's just a bot, right? So these web of trust systems without SIB resistance don't work. So World ID is really useful for this. So you can duplicate these attestations. So you make sure that all these sort of trust networks or attestation networks, I can say that you're good at football, whatever, right? So if there's a lot of unique humans saying that you're good at football, then maybe you can have official rankings for things like who is the best football player. Right now, there's no way to actually do this when it comes to like public opinion, right? You can just guess. But in the future, we can actually create polls that are SIB resistant. So people like Cristiano Ronaldo is the best football player, or like Messi is the best football player, whatever, right? So people can actually vote, and it's SIB resistant, right? So it's officially like representative of people's opinion, as opposed to just like vibes. Then there's ads, right? So advertising is like the biggest sort of revenue model of the internet. People who put ads out there, and also platforms who host ads, really care that the people seeing the ads are unique humans. They're not bots just browsing the web and just wasting like revenue or ad dollars spent by the people who are posting the ads, right? So if I know that I'm a unique human and I'm authenticated within a website, whatever, I know that it's not a bot that is seeing these ads in Facebook or whatever. So it's more sort of efficient. So it means like it's really good, right? And you can also maybe create like anonymous like ad preference profiles, whatever. So you don't have to like share your identity or whatever, but maybe you can share some preferences about you and use World ID just so that it targets a unique user, and maybe you can get paid for it, whatever. Like it's something that is useful for there. And beyond just what World ID is today, you can expand World ID to generalize to not just SIB resistance and uniqueness, but maybe there's other attestations and other signals you can use in the future as well, beyond just the orb. Right, so cryptography. I've mentioned some of these ones before. Maybe let me just, I'll try and get to the questions in the end. I just really want to get to the end because I still have some things I want to talk about. So cryptography. Within cryptography, the things that we care about are, as I mentioned, we work with edge devices, mobile phones, and the like. So these devices don't have a lot of computational resources that we can use to build applications that are really heavy on cryptography. Hence, we really care about improving the state of the art of cryptography for these systems. So this is directly coupled with the first 3 points. Mobile proving, right? So creating tools and better cryptographic tools that allow you to make proving on mobile phones performant, fast, cheap, inexpensive, doesn't consume a lot of memory, doesn't consume a lot of maybe internet bandwidth, like you don't have to upload big proofs or download big proofs. You don't have to download or upload big like ZK tools or whatever, like the binary of the app doesn't have to be large for the prover and the verifier or whatever. You can just couple these things and make them a lot more performant, a lot faster, a lot smaller, a lot cheaper. These are things that we care about. And I've talked about them before in the ZK cryptography session I did. Then there's delegated proving, right? So if you really don't want to do the proof on the phone, it's maybe too big to do on the phone. Is there a way to delegate it to a server in a way that is still privacy preserving? So we're working with Firma on that. They also made an announcement earlier this week, I think, or maybe last week about this. So I really recommend you check that out. So delegated proving is just, instead of doing the device, the compute on the edge, on the phone, you do it on a server, but in a way that you don't leak the personal information or the private information from the user by using maybe like multi-party computation and ZK in unison in one system. Better zero knowledge proving schemes. Here's a list of some of the ones we care about. I'm going to go through that really fast. Zero knowledge virtual machines. So currently, these are too expensive to use in an edge device scenario, but they're becoming ever more powerful, ever more performant, right? Some examples include like SecSync's SP1 or maybe like RISC-Zero's ZKVM. There's Valida, there's like a lot of them, Nexus, many of them. So essentially these zero knowledge virtual machines allow you to create just one program in a regular programming language like Rust or C++ or whatever, and just put it into ZKVM and create a ZK proof of that. So you don't have to write code that is specific to some zero knowledge proving scheme or a library. You just write regular code and it's ZK provable by default. So this is a big unlock for developers. So a regular developer can just use zero knowledge cryptography without knowing zero knowledge cryptography. Very simple. So better tools for that. We care about that. Iris hash. So this is a privacy preserving way of the way that we do Iris codes right now. So currently Iris codes are not cryptographic hashes, meaning that they're not random information that is like statistically indistinguishable from a random distribution or a pseudo-random distribution. So Iris hashes would be a Iris code-like system that allows you to check uniqueness, but you actually learn no information about the original the original biometric that you took it from. There's some bits of information the Iris codes leak, but the Iris hash would not, or at least would a lot less in some cryptographically provable way. So that is that we care about. MPC we talked about, ZKML we talked about. Propagation I mentioned also in the ZK cryptography one, so I recommend you go to that one to sort of see more on propagation. Oops, I went one back. Maybe I had the same slide twice. Give me 1 second. Sorry. Yeah, I had the same slide twice. Forgive me. There we go. Right. So future of OP Stack. So this is related to WorldChain, right? So I presented this last time, like last presentation on the OP Stack. Since we don't really have a lot of time, maybe I'll skip over the general slide, but I'll talk about WorldChain itself, right? So you can watch the previous episode where I discuss each of the points at length. So WorldChain is this L2 or scalability solution that we're developing or building that uses the OP Stack underneath to sort of scale the WorldCoin ecosystem, right? So we can onboard more users on chain and do more things. So within here, so what are the things that we care about? This is also a slide that I had in the previous presentation, but just to reiterate, we want to launch mainnet as soon as possible. And the thing that we're primarily gonna care about is this thing called the scalability roadmap or the gigagas per second roadmap. So maybe I want to talk just briefly about what this means and why do we really care. Like I just want to drive this point home. Like why do we care about scalability? So since we want to onboard 1 billion humans and maybe more on chain, right now, just some napkin math numbers. Let's say that we have 13.5 million people who have downloaded the World app on both iOS and Android combined. 6.6 million of them are verified by the Orb. And so all of them have together, like, I think over 100 million transactions, maybe not quite just yet. I'd have to double check that, but close to that, like in the order of magnitude of 100 million transactions. So if you imagine like the number of transactions and the number of users in the network grow exponentially, like related in an exponential fashion, right? It's not linear. So if you grow the number of users by 1 million, it doesn't mean that there is like a linear amount of more transactions. No, because the more users there are, the more they interact between one another. There's more like edges between the existing members, right? Like they become more interconnected because it's more useful to them. So not only do you have to scale linearly, but you have to scale exponentially so that you can actually support 1 billion humans, right? This is the problem with the internet. This is why it took us like 15, 20 years to build social media networks that actually support 1 billion humans, like Facebook, Instagram, whatever. There is so many unsolved problems on the internet that sort of needed these exponential technology growths to be able to support this. So the same thing is going to happen with the blockchain, or it needs to happen in order for this to be feasible. The timeline for this is unknown, right? Like technology is really unpredictable. You see AI is like growing really fast. This is growing really fast, but we're quite optimistic. There's a lot of low-hanging fruit in the next 5 years. And maybe by then we're moved so far and we have so many new tools that we can continue the exponential above. So this is sort of like the motivation, right? Like if you scale to 1 billion humans, you're going to need exponentially more on-chain resources to actually provide a decent user experience for those users, because they're going to be wanting to do swaps and lending and safe deployments and ZK proofs like attestations, and combining those in really esoteric ways. There's going to be new applications like prediction markets, AI on-chain, whatever. There's going to be a million things. So we really care about being there for the users and actually providing for them. So this is why we care about scalability so much. And this is why I'm reiterating something that I did not maybe talk in depth as much last time on the OP Stack and WorldChain presentation. So yeah, scaling Reth, the execution client built by Paradigm, which we're also trying to use for the WorldChain, but currently we're going to deploy with Geth, which is the one that WorldChain that OP Stack currently uses. Essentially like rustifying the OP Stack, taking it, scaling it to 1 gigagas per second, like scaling it so that we can support the 1 billion humans in the future, and working on better user experience and developer experience tools, things like account abstraction and other things that I talked about previously. 10 minutes left. Great. So decentralization, right? So far I've been talking about build better tech, better tech, better tech, better tech. But all right, it's better tech, but it's been built by the same people over again, all over and constantly, right? It's Tools for Humanity, WorldCoin Foundation, maybe 3 other more entities, and that's it, right? When is it gonna become decentralized, right? Like when is it gonna feel like Ethereum, where you wouldn't call like Vitalik Ethereum CEO or anything? Like Vitalik is just a contributor, just like you and I, to Ethereum. When will WorldCoin feel the same? Well, there's a lot of things that you need to do to take us there. I think the hardest part of this is the hardware component, because decentralizing software is easy enough because phones and computers and servers are fairly distributed homogenously across the world, right? Like there's people with computers in India and China and the US and South America and Europe and Africa. There's people with computers everywhere. So running an Ethereum client everywhere is trivial because it is not that expensive to run. So it's not the same for the Orb so far, because nobody has an Orb beyond a few select countries that we are in right now. So how do you actually decentralize the Orb? Like when it comes to availability, manufacturing, deduplication, redundancy of manufacturers and logistics providers and operators and different entities that control them. So this is sort of like the hard part. We really care about this, and we have a whole tech tree. So if you go to that link, worldcoin.org/tech-tree, you're going to be able to learn more. And these are sort of some of the items that we care about decentralizing, so that you can consider World ID and WorldCoin somewhat decentralized, right? You need to have decisions that are made by some governance framework that is controlled by people holding a World ID or maybe WorldCoin tokens or whatever. That is what governance is. And so currently, all the decisions are mostly taken by the foundation, us, WorldCoin Foundation, and Tools for Humanity, and maybe some collaborators. But in the future, it should be the community at large through some governance mechanism, right? Like Ethereum has all core devs for all core like developer changes. They have all core devs who make decisions, and then stakers need to run that code as well. So there's a lot of parties that need to agree to something to make a change happen, and it takes a long time. And there's like vetoing, and you can like the change happens slowly, but it's a fair process. So how do we get there? It's sort of the thing. We have a whole tech tree which like goes from where we're now to how do you get to a point that looks much more like Ethereum. This is sort of like something that we really care about. So decentralizing operations, the protocol, world ID. We need to increase auditability and transparency, like I mentioned on the first slide. Decentralized ore manufacturing, logistics, a world chain itself, right? Like decentralize the sequencer, the fault prover, or maybe like eventually a ZK prover. Decentralize the everything around world chain, right? That you could create an orb registry, so there's maybe like other entities that can post like identity commitments that are derived from an Aris code that people can use to sort of insert or curate unique sets of humans that have used other orbs that are manufactured by other people, maybe. So these are like sort of things that we care about when it comes to decentralization. So before I get to the end, just note that the last 7 episodes, and this one included, they're only a really small fraction of everything there is out there to learn about WorldCoin. There's so many things that are impossible to share in just like 8 hours of content. There's so many other things you can learn about all of the other topics we've talked about, like whether it's biometrics or cryptography or hardware, software, or whatever, operations, logistics, like all these things that we have, and challenges and things you can learn. This is just like a, maybe let's say 1% for like maybe like some rough context of how much now you know of what there is out there to learn about WorldCoin. And the body of knowledge keeps ever expanding, and this resource, maybe in like a year from now, it's outdated, and sort of like we cannot keep up to date with everything when it comes to outbound education. So we're trying to do as much as we can to share information to you guys so you can learn more on your own, and maybe you can teach other people about it if you're curious, or if they're curious, or if you're interested in it. So this is sort of where we keep all of the information, and we try to keep it as up to date as we can, at least all the important ones. All the details are released through blogs. So another great resource is worldcoin.org/blog for like new updates on things that have been happening that we're doing. So I really want to drive this point home. Yet again, whitepaper.worldcoin.org is the place where you can read the most on WorldCoin as an outside observer. If you want to learn more about specific things, then maybe it's good to like reach out to us and ask questions on our Discord, or maybe if you see us at conferences, or shoot me a DM on Telegram or on Twitter or X, or any other team member that you get the contact for. Cool. So before we really get to the very end, I wanted to say one last thing. So this wouldn't have been possible without ENCODE Club. So we are working with ENCODE Club through our WorldCoin Foundation grants program. So as I mentioned in the very beginning, we have this grants program, and one of the teams that we awarded our grants to is ENCODE Club to produce these educational resources, right? So getting all of you guys actually as an audience, right? Like we don't have this audience, so we got ENCODE to sort of help us produce this wonderful content, and also to get you guys and girls to listen if you're interested, right? So many of you signed up, and so we really want to thank ENCODE Club for providing all of this awesome space for us to talk about these things. So thank you once again. And yeah, that is officially the end of the series. Now I have 4 minutes left, so I had some little amount of time at the very end to answer the last few questions. Cool. So let me start with Brian, maybe, or Rebecca. Do you have something you want to say?
Nope, I was just coming on stage for the end for a smooth transition, but you can go through the questions.
Awesome. Cool. So Brian, how can ZKML be utilized to secure or enable secure collaborative machine learning without compromising the privacy of individual data and contributors? So yeah, that is a good question. I have this really great resource that I made. It's github.com/zkml-community. I also created this community back in the day. awesome-zkml. So this is an index of all the ZKML resources that I've found throughout the internet and through friends and stuff. So you can use that to learn much more. But the TLDR is ZKML only hides the data from the verifier. It doesn't hide the data from the person creating the proof, which is unfortunate because zero-knowledge machine learning and machine learning itself is extremely computationally intensive. It's really hard to create, like let's say you have GPT-4 or maybe O1 preview or maybe Claude 3.5 or any of the state-of-the-art models. They're extremely large, and so you need like these really beefy graphics cards like H100s, H200s, whatever, to run them, even not just to train them, but to run them. And so creating a ZK proof of that is extremely expensive, like extremely expensive and unfeasible today. So if you want to create a proof of that, you're probably going to have all the data public to the prover, which is some server somewhere in a data center. So you don't have data privacy for the whole system. There's other schemes that give you privacy, like fully homomorphic encryption or MPC, but those are also not really used within ML that much. So yeah, it's an open question right now, TLDR, but it does give you privacy for the verifier. Like everybody else verifying doesn't learn anything about the ZK proof. Second question, what are the key challenges in implementing multi-party computation for real-time data processing, and how can these challenges be addressed? So the TLDR of that is a lot of money to pay for AWS. So you put a lot of financial resources to pay for expensive servers that have a lot of RAM, a lot of GPU power, a lot of networking bandwidth, like connectivity, like really fast connectivity between them. And you improve the software and hardware that you use essentially to make it more performant. The challenges are that if you want to scale to the scale that we have right now, you need more than the current products and services that are out there can provide you. So you need to reinvent or invent another tool to actually make it feasible. So these are the challenges, right? Like just hard bottlenecks in the hardware, in the software, in the cryptography, in the whatever that you're working with. And they can be addressed by improving any of the parts that can make it faster, more performant, whatever. According to the World ID use case, Diodone, according to the World ID use case for fair distribution, case of refugee donation is which one WorldCoin will use proof personal membership. So WorldCoin itself is not necessarily focusing on refugee donation, but if someone wants to, you can have maybe some network of refugees and you can verify that those refugees are unique. I don't know if that's something that is something you can do with the orb. Maybe that's something more for like humanitarian entities to create like a registry that can be somehow verifiable, that people are not lying about refugees and they're actually, the money goes to the right person and it's not just going to some middleman, maybe like, I don't know, like the Red Cross, even though they're good, but maybe it's still not as transparent. Maybe it goes directly to the people, right? So maybe you create an address for every single refugee somehow anonymously, but still make sure that every single one is controlled by a unique refugee and the money actually goes directly to them and not through the Red Cross. Maybe Red Cross just facilitates the provisioning of the resources if those refugees have some financial resources that have been shared with other people. I don't know. It's a hard thing somebody can solve. But maybe, I don't know if World ID is useful here, but could be maybe like 5 years down the line. Cool. So I think, there's a questions tab. I always forget. Would TeraGas be feasible overkill for scalability? Nothing is overkill because the more bandwidth you have, like, look, we've had the internet since the 80s, 90s, really. And you had like kilobits per second or bits per second at one point. Now you have terabits per second of internet, and it's still not enough. Like people still want more, right? Like, and the more bandwidth you provide, new applications emerge. So it's an ever fulfilling wheel, never ends, right? Like you constantly need more. So I don't think nothing is overkill when it comes to tech. There were votes by verified people in Portugal and Spain. How was that realized? So we were already in Portugal and Spain before we got shut down by the regulatory authorities there. So we conducted a vote using the world IDs of the humans that we had on board until that point for those votes. Will this happen in other countries? I don't know. I'm not the person who works on that side of things. How might advances in AI impact future privacy practices? Important thing. It's sort of like why the WorldCoin was even founded in the beginning. Not just privacy, but like fairness on the internet or just usability of the internet. Cryptography is the thing that we're mostly using nowadays to enforce privacy because everything is so digital. Like physical privacy is not as important nowadays because we assume that nobody sees into our house unless they have some camera or whatever. So yeah, cryptography is the way that you mitigate AI negative impacts. And how might AI impact? Well, you're seeing it today with LLMs and bots and whatnot, right? So like people can use data about you that they collect from applications you use to maybe make inference about what you're going to do next, and then use that information against you in a myriad of ways. What regulations govern the use of biometric data in different regions? Just Google that, or ask Perplexity or Claude or whatever. Europe has their own regulations called GDPR. Maybe the US has some. I'm not a legal expert by any means, but Europe has a GDPR clause for personal data, identity, whatever. So you can read maybe that as a good start. I'm European, so I'm only familiar with GDPR. So yeah, we have a code in the settings section that says proof of ownership. Can this code change? What are likely use cases uses besides it deleting to the iris code? I'm not sure what that means. But yeah, I'm not sure what that question means. Cool. I think that's it. Awesome. Thank you.
Thank you very much, DC Builder, once again for your 4th workshop in the Educate series. And a big thank you to all of you guys who've attended live and also the people who've been watching the recordings on our YouTube channel. Anyone who's new to the ENCODE community because of this WorldCoin Educate, and anyone from the ENCODE community who have gone into the world of WorldCoin because of this Educate series with us. It's really cool that you're expanding your horizons. And yeah, we love to see it, and all of your amazing questions at the end of all the sessions. As I said, all of you who are attending live, you can receive an NFT certificate of your participation. And we'd love for you to post them online and share with everyone that you've attended and maybe a bit about what you've learned. We'll be posting a summary of all of the sessions, and of course, all of the recordings are online. But yeah, unless DC Builder has any final comments, thank you to all of the speakers who've joined us on this Educate series.
Yeah, I just wanted to say like one last time, thank you everyone. Thank you ENCODE. I also want to thank all my other team members who joined to present and create content as well. And in general, thank you everyone for attending, for asking questions. Like Rebecca said, thank you for interacting, engaging, learning, caring about things. I don't know. Just thank you for being part of the community, and maybe see you next time somewhere at an event or somewhere online or in Twitter or somewhere else. Awesome. Take care.
Nice. And of course, do share these videos with anyone in your community who might be interested. It's a great way to sort of learn the basics of WorldCoin and then explore the white paper to go a bit deeper, and of course contact anyone in the ecosystem to ask questions about anything that you're interested in. I'm sure they're more than happy to help. Token 2049.
Yeah, I'm not there. I decided to not travel this month. Like I'm gonna be at DEF CON though in Bangkok, and also ZK Summit, but I doubt any of you are gonna be in Lisbon for a Zero Knowledge conference in October.
Well, if they are, I'm sure they'll be able to find you. These friends will be there. Okay, so we will end it there for today. We'll send an email round with all of the information about the end of the series. One final massive thank you, and enjoy the rest of your day, week, year. If you join us in another ENCODE program, then I'll see you then.
Take care. Bye-bye.